Today I'm going to explain you about the floating point number multiplication. So first of all, we have to know what is floating point number. Floating point number usually has a decimal point. So let us see the examples of floating point numbers. 3.14. This is a floating point number. 0.005 and 12.5 to 50.0. These are the examples of floating point number. And why we need floating point numbers means computers directly didn't take integers or numbers into the computer. So we have to convert into the binary form and give it to the computer. So if this floating point representation using this floating point representation, computers can store decimal numbers, handle very large numbers and handle very small numbers. So we have a standard representation for the floating point numbers, that is minus 1 power sign into mantissa into 2 power exponent. That means f equals to m into base power e. This is the standard representation of floating point number. Let us see exactly what is the standard representation. So here f equal to m into base power e. This is standard representation of floating point number. Let us see the example of floating point number. 0.123 into 10 to the power of minus 4. 0.123 is a mantissa, 10 is a base, e is a 10 to the minus 4. Minus 4 is the exponent. This is the standard representation of a floating point number. Let us see how we multiply the floating point numbers. Actually, floating point multiplication doesn't require an alignment of mantissa product. Mantissa doesn't require an alignment. It require only multiplication of mantissas and adding the exponents. This is the this format we use in the multiplication of floating point numbers. So let us see generally multiplication of floating point numbers. 0.12 into 10 to the power of 4. This is the first floating point number, and 0.23 into 10 to the power of 3. This is the second floating point number. So what we have seen here, multiplication of mantissas. 0.12 into 0.23. This is multiply these, so we get 0.0276 into. Now we add the powers. 4, 3. So we add the 10 power 4, 10 power 3. 4 plus 3 is 7. So 10 power 7. 0.0276 into 10 to the power of 7. So this is the actual steps to multiply a floating. So let us see. It is in the form of this flowchart. It is in the form of flowchart. And so first take two floating point numbers. See the multiplication of floating point numbers in the form of flowchart. So let us first we have to take the first two floating point numbers. So the first floating point number is stored in the binary register, that is multiplicand, and second number is multiplier, that is stored in the quotient register. This is the first number is multiplicand and second number is multiplier. So we use these two registers, BR and QR. BR which stores the binary numbers, and QR is a temporary register which is special register in the CPU. So first what we have given, that multiplicand is stored in the BR and multiplier is stored in the QR. So if either of the numbers in BR and QR is 0, then the result will be 0. That is stored in the accumulator. If one multiplicand or multiplier, either of them is 0, then the result will be 0 automatically. So first we have to check the zeros in either of these register, if the zeros are stored or not. So we have to check the zeros first, and second we have to add the exponents. Let A and B are the exponents. So add these two exponents. Next multiply the mantissas. This is the next step. And if you get the if you need a left shift, we do this left shift, and the result will be stored in this end. The result will be stored in accumulator finally. So what is left shift means, if after the completion of multiplication we get the answer like this. If suppose we take any, we take any two numbers and multiply them, then the answer is getting like this, 0.011 into 10 to the power of 3. So in this place 0 should not be come, so we have to remove this 0. How to remove this 0? Here 10 power 3 is there, so 110 is multiplied to this number, then the number is getting like 0.11 into 10 to the power of 2. Here 110 is reduced, so a power is reduced to 1, so 0.11 into 10 to the power of 2. This operation is called left shift. So then finally this is a normalization. Normalize the result. This should be done after multiplication. Normalization should be done, and the answer is stored in the accumulator. Finally, floating point numbers. Computers work with a decimal and very large and very small numbers. They are important for accurate calculations in science, engineering, and daily computer applications. Follow my channel for more videos. Thank you.